Hello guys. So today we'll be looking at Docker containers and as well as we'll be looking at other topics such as Docker engine, Docker compose and parts of Docker engine. So let's begin. So a container is a standard unit of software that packages up code. In other words, a Docker container is also known as containerization. So containerization includes all dependencies like frameworks, libraries and etc. These are required to run applications in an efficient and bug-free manner. With Docker container, applications can work efficiently in different computing environments. Here is a simple graphical representation of a container. So a Docker engine can host many containers. Each container has its own application, its own dependencies, its own libraries. The Docker engine is based on the host OS kernel. So as we know, OS kernel is the most basic part of an operating system of any device or a computer. So a Docker is lightweight. Docker containers are light in weight so that they can be easily deployed and executed in other computing environments. They occupy less space. So as a, as it suggests that it takes up less space on the host storage. Run applications in isolation. So each container can host different OS. They all are isolated. They do not influence each other, but they can interact with each other. They are highly secure. The Docker containers are highly secure. They are highly portable. That means that they can run wherever, uh, like they can run across the Docker ecosystem anywhere. Boot up takes less time. So this is the basic representation of Docker ecosystem. It has a Docker registry, Docker host, and Docker client. Docker registry are the registry from where we can pull Docker images. Docker host has the Docker images, containers, daemon, and volumes. Docker client is the command line interface which we use on our computers. Uh, for OS, it can be the terminal, Mac OS. For the Windows OS, it can be the PowerShell, or for Linux OS, it could be the command line interface. So we are the users and we interact with the Docker ecosystem using a Docker file. So for now, we'll be looking at Docker engine. So a Docker engine is a client server application that builds and executes Docker components. So essentially a Docker engine has three components in it: Docker client, REST API, and a Docker daemon. So Docker client is a service which uses REST API to send commands to a Docker daemon through command line interface. As I have said that this is uh, this can be considered as a client or us the programmers. Our command line interface acts as a Docker client. For Docker daemon, checks the client requests and communicates to the Docker components in order to perform a service. So this is like a processing hub for a Docker and REST API. REST APIs are the set of definitions and protocols for building and integration of application software. You can think of an API as a mediator between the users and clients and the resources or a web service they want to get to. It's also a way for an organization to share resources and information while maintaining security control and authentication, determining who gets the access. So here we are going to look into the Docker Compose. Docker Compose is used to run multiple containers as a single service. Here each container runs in isolation but can interact with each other with no limitations. This is a model for REST API. We'll be looking at basic commands to interact with containers using Docker. So now we will be looking at commands for running containers in Docker using Docker. So before starting, uh, if we want to work with default containers, default containers are available in the Docker Hub, which is a public repository. So we can go to Docker Hub. Here we must ensure that we are logged into the website. So here we can explore in the explore section. There are multiple images available to work with. So the basic one can be hello world. So this command here, the docker pull hello world, can be used to pull this image into our local repository. So there are multiple filters here for different architectures, for different operating systems, different products. So we'll start. Uh, so the basic command is docker version. So we are currently running the 20.10.17 version. So let's start with the first one, which is the docker ps command. So this shows us the list of the containers running. Currently we don't have any containers running, so the list is empty. For starters, we'll run a container docker run. The docker run commands are used to run images. So we'll run the image of hello world. So if the image is not in our local repository, it will pull it from the public library. So if we check now, still it's we cannot find in the container as it is not yet running. So for the containers which are not running, if we have to see them, docker ps slash minus a command will help us. So here we can see that the container of hello world image is running. It is allocated with a certain container ID, and it is defaultly allocated with a name called the Reverend Heisenberg. So we can also name the containers the following command, which is docker. So for example, we'll try to pull the Ubuntu image and giving it a name. For the name, we have to write docker run minus name my Ubuntu minus IT and Ubuntu. So here the minus IT sign represents the interactive mode. So we can actively see the name. So the Ubuntu image is also not present in our local repository. So it is pulling from the public repository. So now we are in the container with Ubuntu running in the container. So if we press ls, we can see all the options here. So now I'll exit this container. So if we check docker ps, so that there are still no running containers. So we have to check docker ps a. So here we can see two containers and even the Ubuntu image having a container with the name of my Ubuntu. So now uh, we can, the other command is docker start. So here you can give the container ID or the name of it. So as I have given name to my Ubuntu container, I'll write the name Ubuntu. So if we check the docker ps command. So here we can see that the Ubuntu container has started. So similarly, we can even stop this by docker stop container name or ID. So again, if we check for ps command, we can see that the container has been stopped and it's not working. Actually, let's start this again. So let's actually enter into the Ubuntu. So docker run Ubuntu. So now we'll be looking at the docker top command. It is showing us that it is not running. So we'll first run the command uh, docker container. Oh no, it is running. So it shows us all the top processes which the container is performing right now. The next one is the docker stats. So it shows us the statistics of the running container, like the name, container ID, memory usage, the network, and everything. So to exit this, we have to press the Control C button. So there's another uh, command called the docker kill. So this kills the running container to check. We can verify the PS command or even the PSA command. So as this is showing us that this is exited, this means that the container has been terminated and killed. So now we can remove these with the rm command. Rem. So if we check, the container named my ubuntu has been removed. So these are the basic commands to interact with the containers. Hope you like this, and thank you so much for watching.